The sun just unleashed a colossal plasma storm the size of 10 Earths, and it's a stark reminder of how powerful and unpredictable our star can be. But here's where it gets controversial. Despite the massive scale of this solar eruption, the impact on Earth was surprisingly mild. What does this mean for our understanding of solar activity and its potential risks? Let's dive in. Last week, scientists and space enthusiasts were captivated by an extraordinary sight on the sun's surface, a gigantic inverted S-shaped structure stretching an astonishing 78,000 miles across. To put that into perspective, this formation was about 10 times wider than our entire planet. This striking pattern, known in solar physics as an eruption sigmoid, appeared near the sun's equator and was a clear sign of intense magnetic activity. Within less than an hour after this structure emerged, the sun released a massive coronal mass ejection, CME, a huge burst of magnetized plasma hurtling through space. This CME traveled roughly 435,000 miles before it reached Earth 3 days later, on September 7th. Where it interacted with our planet's magnetic field and triggered a geomagnetic storm. Despite the dramatic nature of the event, the storm was classified as G1, which means it was relatively mild and caused only minor disturbances to Earth's magnetic shield. So, what exactly are coronal mass ejections, and why do they matter? CMEs are enormous expulsions of solar material and magnetic fields from the sun's corona. When these charged particles collide with Earth's magnetosphere, they can disrupt satellite communications, interfere with power grids, and even create dazzling auroras near the poles. However, the recent storm didn't produce any spectacular light shows in mid-latitude regions, which is often what captures public attention during stronger events. Adding an intriguing twist to the week's cosmic happenings, this solar eruption coincided with a total lunar eclipse, popularly known as a blood moon, visible in many parts of the world. While the eclipse and the solar storm are unrelated phenomena, their simultaneous occurrence sparked curiosity and highlighted the fascinating interconnectedness of celestial events. Delving deeper into the science, the inverted S shape is a hallmark of twisted magnetic fields on the sun, often linked to sunspots. These magnetic fields can become unstable, eventually snapping and releasing vast amounts of solar material into space, a process that often precedes significant solar eruptions like CMEs. Scientists rely on these visual cues, which resemble the Greek letter sigma, to anticipate solar activity and better prepare for its effects on Earth. This recent event underscores the importance of continuous solar monitoring. As our society becomes increasingly dependent on technology, from GPS navigation to power grids, understanding and predicting solar storms is more critical than ever. Even a mild geomagnetic storm can cause disruptions, and a more intense event could have far-reaching consequences. But here's the part most people miss. While this storm was mild, it raises important questions about how often such large-scale solar eruptions occur, and whether future storms might be more severe. Are we truly prepared for a major solar event that could knock out critical infrastructure? And how can we improve our forecasting models to mitigate these risks? The sun remains a source of endless fascination and mystery. Each new observation, like this massive inverted S eruption, adds valuable insight into the complex magnetic dance happening on our star's surface. As scientists continue to study these phenomena, we're reminded that the sun's behavior directly influences our technological world and our understanding of the universe. What do you think? Are we paying enough attention to solar activity, or is this a risk we're underestimating? Share your thoughts and join the conversation below.